Okay, my friends, stunning discovery. Perseverance up on Mars found a zebra-striped rock, and NASA is excited. Okay, 10 years ago they found this in the same area, and they claim this is continually over many millions of years deposited little this and that, and that's what you end up with. I say no. Let me show you what this really is. Okay, my friends, before we go, I want you to know that there is no erosion here. This is no question whatsoever. This is Mars. There would be some form of erosion if there was any moisture whatsoever. Anywhere on Earth, sooner or later. They're saying continually over millions of years, these layers are laid down. I disagree with that. I'll show you exactly what they are now. All right, as you know, my claim is there is nothing but biology, and Mars is biology just like Earth is. And these here are mussel sarcomeres. And this was called the Mars crab, which is right down here, in the midst of these mussel sarcomeres. Now, what is this Mars crab doing there? And what's that tube on top? What's that? Why are all these little crabs sticking out? Why is this reddish looking and that black? And why is all this erosion in between these little tiny thin layers? What eroded out of there? Well, all that little red stuff. And again, no, it's just dusted off. It didn't erode out like from water and run off into little rivulets. This is Mars, trust me. 10 years ago, I told NASA, I said, this is biology. That's an artery, that's a vein, these are mussel sarcomeres, and let me show it to you. Okay, my friends, that's what's up on Mars, and that is mussel sarcomeres. The red stuff just dusts out and leaves the sarcomeres behind the connective tissue. This is a pulled-in sarcomere. You know, that's your muscle contracted, and that's a muscle extended, just relaxed. Now, if you don't understand what you're seeing, I can't imagine that. This red is the fluid of blood, basically. This is almost solid blood within the sarcomeres. As a matter of fact, let me show you some. Okay, what happens is the red blood runs out sometimes, and these can collapse. That's what happened over in Turkey. Everything is made out of giant biology. That's just the way it is. These are those mussel sarcomeres, and these are where the red blood fits in here and there. Look at this one. That's red blood coming in to service this tissue. There's red blood over here, red blood over here, and there was a layer underneath here that just washed its way out, and everything just collapsed. A big, huge thing. This was not an earthquake. This was a collapse. And those are mussel sarcomeres. Everything is made out of biology, and some of it is just beyond belief how big it is, but it was written in the ancient text that everything's made from creatures, basically. I don't know, it's just what it is, my friends. All right, this is the artery and the vein, and it's supplying blood for these sarcomeres, which is absolutely essential. Well, guess what? So is mine in my shop here. This is a rock here, but here is the same layer of blood. That's an artery right there, and it was supplying blood to all this muscle. This side is muscle. Right there is tendon. See how it's brown? There's no blood in tendon, almost none. And the blood fed this. You see a lot of blood coming in to feed the muscle. And these are all sarcomeres too. Of course, you can't see them. They're very, very tiny. This is that, only it's extended past here. But this was where the bone was. And that tendon locks with a pin right into the bone. It's crazy. I can see more detail in the mud fossils than they can see in anywhere on Earth with microscopes. Can't see the same thing. I got it better. This is on Earth, but it's just more big, gigantic creatures. That's that thing with the pin right there. And the bone has eroded and the muscle has eroded, and that's the tendon. Much, much tougher. And all of these little slabs are so that it can slide amongst itself, and they're all strappy as hell. And this was where the muscle was. And that pin locked into the bone, just like I showed you a second ago. The pin locks into the bone. You see right here, that's the pin. That's the main center of the tendon. the bone's over here, which is this bone. Now there's something else going on where that pin, it looks like it latches over to this, and then there's a lock here somehow, I don't know. And this is tendon stuff, but this is all muscle. That's muscle, and the muscle fibers, it's tiny, tiny, tiny little sarcomeres. And here, where you see the white, that means there's a lot of connective tissue. You have abrupt transitions. You have your bone, then you have a little piece of tendon, which gives you that just little and then you got your muscle, which does a large contraction, expansion, and that's this. However, when it first starts, from the tendon, which is brown, almost no blood whatsoever, you still have a lot of connective tissue. By the time it gets a couple of abrupt transitions, there's an abrupt transition basically, it gets less and less mineralized, and then all of a sudden it just gets into ropes of muscle fibers. And they can tear, but there's still, connective tissue in there. It's not like they're empty and they're just gooey stuff. They're strappy. They're sarcomeres, just like I showed you, well, the ones on Mars. Okay, so if you know a doctor or anybody that's a biologist or any of that, just ask them, is this what I'm saying it is? Because it is, my friends. This is biology, and it is universal. When I say universal, the entire universe. Now, the suns and so forth, the suns and stars, I can't explain those kind of things, but I can explain this. This is biology. Okay, my friends, as far as I'm concerned, there is nothing but biology. And that accounts for even like the comets, meteorites. I have meteorites here that are lungs. They're small. This one right here, that's a tiny little meteorite. And it came through space and smelted. But it's a lung, and it has the spur lock on it. I've shown this, again, hundreds of times. They all have that same thing, the lungs, and I have a lot of lungs. Lungs, anything with the blood preserved very well. Now, and of course, the rocks that are literally meat. And there again, that little triangular latch is what latches this chunk of meat into the next where it binds with here. And it's very, very tough right in that spot. I have all the details. My stuff, some of it's CAT scan, DNA tested, it's all done. So it's time that we stop spending billions of... Yeah. Okay, I know this is very difficult to accept, but it is true. This is what they call interstitium fascia. And it's the stretchy little parts of your skin that can pull in this way and that way. But these little balls are where it's attached, so they stretch and they come back. That's what happens when this thing erodes and all the fleshy stuff goes. You end up with what they call Moki marbles out here in Arizona and Utah. They're all over the place because that was just a gigantic creature. I'm sorry, it's what it is. And this is over in the United Kingdom, Huntington Beach, and these are the same balls as these, only this is in the ocean. And what happens is as the flesh gets eroded, and that's all it is the erosion of the flesh. The balls drop to the bottom. The flesh still has a lot of nutrition in it. And these are just being populated by sea creatures that, moss and whatever it is in the sea that can live in salt water. And this is the mud that's running off of that. Simple as that. This here, everything had run off a long time ago and just left the balls, which the balls will eventually turn into stone because the nutrition is gone and the creatures can't live on them anymore. And this right here, these are these balls. They're literally everywhere in your body, underneath where your fleshy stuff sort of gushes around. It's how it's held together. And it can get very large, as you see. And this is what's up on Mars, is the Mars Morse code. This is nothing more than that interstitium. And this is where the skin is gathered and gathered and stretched and pulled all the way stretched. I show my belt at the loop where the thing goes through. It's a cowhide belt. You can see these little straps and the balls. You can see them all over. Tanning forces and crushes these balls, but the straps stay in there. That's why a belt can twist and do all those things, and it's really tough. And I show that hundreds of times too. And don't forget, everything, there's nothing that I can find that is not biological. This is a membrane, and there's 2 layers. It's called bilayer, 2 layers, phospholipids, fatty phosphorus. This is the phosphorus, basically, and this is the fatty area in between there. Now, this can be extremely large or extremely small. In us, you hold that up in front of you, you can look through it. It's almost not even there. Very, very thin, but very fibrous. This is tight. These are what's called tight junction cells. They're tight with this phospholipid layer. That's a membrane. It won't allow anything to come through or anything to go out unless it goes through these channels that allow it because of the chemistry. Well, you see the size of that. And like I say, you need a microscope, a very good microscope to see that. Okay, we just saw the phospholipid, the 2 layers. This is the layer up above, and this is the layer down below. That, my friends, was a membrane of some kind of a creature. I'm not just telling you. Now, in addition to seeing the quite obvious pattern here and the 2 layers, I think this is 6 feet, maybe more. This is Tyson's Mudfossil Adventures, Tyson Carlson. He's been doing some really good research out here, looking into these gigantic creatures or features that are on the side of the ocean being eroded away. And I want you to look at this carefully. Obviously, you can understand what's going on. You see these little rims around everything? That originally, if you go into the deep chemistry, you'll see there was stuff, all gooey stuff was around here, so that it could flex and do all these kind of things, and the gooey stuff in there would keep it a tight junction. You don't want anything going through unless it goes through one of these big channels here that says, okay, you guys go, all right, go ahead, you're all right, no, you get out of here. And they do it by chemistry. And I have learned so much about biology. It's absolutely incredible. There's so many things I can see that not even the best anatomists in the world have ever even considered. I'm serious. Okay, this is the rock that they saw and are all excited about up on Mars. I say that's a lung, and I can see this green color, and I believe that's copper. And all of these little straps are from the lung. There's some more copper over here. Copper is quite common in lungs. Now, what does a lung do? It goes whoop, 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 whoop. And this is like a big rubber bag around it, which is this right here. This is the pleura. And it's like a rubber bag. And that is a lung. It's been DNA tested, CAT scanned, human DNA in that lung. And it's flat because of the event that destroyed Mars, and just prior to that almost hit Earth and caused catastrophic consequences on Earth. Now, you say, why does that one look like that and this one looks like this? They can be in every state of decay, and they can be in every different type of material. This is also a lung. This is how thick that pleura is, that stuff there. And again, it just does this all day long. And this part has eroded away, you see it? And this is the actual lung. That's where it would attach at the top. This is where it attaches at the bottom, the spurlock to hold it in. And this is the alveoli, and that is the pleura. Now, again, flat as a pancake on the back. All right, a little bit different mudstone. This didn't have as much into the red, there was called a red bed. The red bed was the low part where all the flesh boiled down, and then you get the mudstone settles into there, like this bone. It's primarily a mudstone, but it was a bone at one time, completely bone. But when they settle in that red bed and they just continue to do nucleophilic invasion and substitution, they take on whatever they're in almost. And that's why you can never tell what it's going to turn into. If it's higher up, like this was, it didn't turn into quite as much mud. And I can't tell you why some are low and some are higher up, but there's layers. There's a red bed, the gray clay, and a black cap. Black cap is fallout. Red bed is the mudstone, which created the mud fossils. And then above that, the gray clay is the fallout from trees and erosion of all kinds of things. And then above that, the black cap settled down. And I have things, I am in that area, Triassic era. Anyway, this is that. Now, let me show you what I have here. This is mine. Now, don't forget, this is this. And this is a lung. That's a lung. And I can show this quite clearly. That's where the plumbing goes for the lung inside here. And it has the spur lock on the end here. Got a little latch that latches it in, see? And this has copper in it as well. And it has all the little straps. You see these little, they're talking about all these stripes. Well, that's this. And that's this. And that's these coming down. But this also shows that there is copper in this as well. This is, and then of course there's the red blood. And the black is the vein blood. Now there's not much red blood in this particular rock because of the way where it was in these layers. So there's not much red blood in here. You really got to look around to find it. But you can find a structure. You can find a structure of the spur lock very easily. And of course the plumbing, and I can show this better in the microscope. And but again, they turn into virtually anything. This one here is a lung, and it just, everything evacuated and left the structure of the lung with all the filtration area where the air goes through it. But there's still a lot of red blood in here. You see that? And there's copper in this too. I was looking at this the other day, and there's areas where there's copper still in this. And there's crystals in here too. Anyway, and this is another lung. There's all kinds of creatures. That's a lung. You don't need doctors to tell you. That's where the main passage went into the lung. They fill up with silicates because at this particular time, the whole area was saturated with silica. Because we almost got hit by Venus, and all of the deep siliceous ooze, look it up, siliceous ooze, which is at the bottom of the ocean, all came up to the surface. And that's what made these things turn. Because anywhere where there was voids, it filled them right in with quartz. That's the beauty of that whole thing. It preserved it. They say veins of quartz. Yeah, exactly. Veins of quartz. They were veins or they were arteries, one or the other. Okay, my friends, I don't know what much more I can do. Even Bennu, they came back with a sample from Bennu, and it is the heart sarcomeres. You can see it. And there was phosphate layers. They said they never expected to see that. Phosphates are the phospholipid layers. They're the membranes, and right in between are the blocks of sarcomeres. Cannot be denied. And this psyche is same thing. These are hearts. They're hearts, saturated with blood. That one's smelted. And they're down to the valves. Now, as again, everything in space. And not only that, you can see these aren't impact craters, that's tubes. And that's a tube coming out. And these different colors are the colors of blood. And that right there is the color, is the tendon that locks in. All the rest is gooey. So the heart can do all this stuff, and it's all gooey and flop around and go out through the tubes. And then once it dries out, the tubes just fall off. You see this gooey stuff? I just showed you the tendon. The gooey stuff was here, and the two valves, these valves come down. That just breaks off and it goes away. And you end up with this. I see it all the time. You got a lot of hearts. Hearts preserve quite well, and it's always the blood. It's metals make them preserve well. All right, let me just run through them quick. I showed you the hearts. Those are out floating around in space. There it is right there. I showed you, I have the almost identical rock to what is up on Mars, which is a lung, and I believe that's what they have there. gigantic membrane, 6 feet thick. In us, it's see-through. These are the Mars Morse code, they call it, and it's nothing more than interstitium, which is nothing more than these little balls and straps, so you can pull here and there. This is muscle sarcomeres, which are these, which is the Mars crab, which is artery and vein servicing the muscle. I showed you the one I have here in my shop. I have everything to support everything I'm saying. And this is the tendon part. The tendon doesn't erode. The muscle eroded, and the bone erodes, and the muscle erodes. That's why this whole thing's sticking up there. That's tendon. That is tough. Now, as far as Turkey goes, that's a major collapse, and you know, I'd like to explain it to him what happened. I think I did. This blood is running out from underneath these sarcomeres. You have to come to the reality that everything is biological. This shows without doubt, zero question whatsoever, that these are sarcomeres, just like this. There's no question whatsoever. They say it's continually over millions of years. No. What would make these stripes here? This is all the connective tissue, and this is all the stuff that would have pulled it together, has just dusted out of it. All right, you really can't dismiss that. If you can miss that, you know, these are the things that I have a hard time with. Can they just miss all this? Because I've been reporting on this for 10 years. Since the first time they reported on a Mars crab, I said, I know what it is. I have one in here in my shop. And since then, there's been dead silence. And here's a bunch of those little tendon enthesis. Well, they're interstitium balls. I call them that. And they're all green here because this is fresh water. Fresh water, they go green on the biological ball until they eat it all up, and then it just turns into those smoky marbles. In the ocean, where it's salt water, you have a different situation. The saltwater ones turn into something like this. And they call them stromatolites, like they just all of a sudden start growing. They're not growing, they're just attaching to what's there. And these are brown. The freshwater ones come totally green. Did you see how many there are? Look at this. Look up here. It just goes forever. Huh. You see, still unexplained. 12 most mysterious things scientists still can't explain. Well, they just won't. Nobody's ever going to explain anything until you realize everything is made out of biology. So that changes everything there is. It changes everything that is, my friends. And it's time to look into this, you know, with a critical eye. I could be wrong, but I don't think the things I'm showing you are wrong, but I could be wrong. Now, I am going to do the next one on the little rock that's coming around this area. It's called 2024. And I have one of those here as well. My motto is, if Roger ain't got it, there's likely there ain't any of it. I'm telling you, you just got to open your eyes and look. This is everywhere. So where have I, let me just finish up and get the hell off of this case. You saw the sarcomeres, and you saw, I tell you, this is what's undercut the thing in Turkey, and that's why it collapsed. I don't know if I even showed you this. This is bands of muscle, and this is the red stuff running out of it, just like it is up in Mars, only this is being washed off with water. So you see all this erosion patterns. Up there it's just dust. This is the guy's van over here. That's all muscle. What else did I not show you? Well, this is a little blocks of muscle. All right, they just, well, actually this is tendon. But everything's made in your body in blocks. Well, not everything, but most things. And these are little blocks. When they break, sometimes they break flat as a pancake. And the different colors mean there's different tensile strengths in tendons. And I'm not sure they understand about that either. Because this is one tendon. But there's brown, pink, this color, purple, all kind. That tells me that there's different transition metals. Different transition metals have different tensile strengths. It's simple as that. There's a lot to learn from mud fossils, my friends. And this was a killer. If you look up what's in the alveoli, it comes in wrapping just like this, and then it just spares off. And you got your red blood, you got your black, which is vein and artery, and then you got your copper, which somehow mixes in so that they can flow into this fan-shaped thing, which is in the alveoli. This was fabulous. That was from Angela. I just did a video on that a couple days ago. I'm serious. There's a ton of stuff to learn from this. There's this latch that's on these lungs. They don't understand that. I know. I've talked to anatomists, and they say it's just part of the connective tissue, and it's not. It's a whole different chemistry. You see that? That's on a lung too. That's the latch right there. This is completely stripped of everything. That's where, I don't know what this is from. It could be from a chipmunk. I have no idea. But they all have the same latch. Organs are held in your body. They can't just go flying around and tipping upside down and everything else. The plumbing goes right in there. All right, this goes. The rubber bag's missing. We're down to the alveoli. You see those little tiny buggers? Those are all little alveoli. And that's the latch that would have held it in place. And this is the interstitium, which would have been right underneath the layer of the outside. This is missing too. We're down to the alveoli. They just admitted this exists in 2018. Meet your interstitium, a newfound organ. It's everywhere in your body. I did a paper on this in 2015. And again, to break into the science it's almost impossible. I have so much evidence it cannot be denied. It's been verified in every scientific way: CAT scans, DNA, chemistry, specimens, all open for available and refused. Not a good look, right? I love you all.